Good afternoon, friends. Once again, I'm back to add on to what we looked at last time in the complex numbers. That is adding on multiplication. Because last time we saw how to add and how to subtract. Now today, if say we are given two complex numbers z1 and z2, and the issue is to multiply the two complex numbers, we are going to borrow the aid of senior 2 math, just opening brackets. Because these complex numbers have two terms, the real and the imaginary one. So with this, when we are asked to multiply z1 times z2, then we shall get what z1 is and multiply it with what z2 is. And in opening these brackets, each element that is in the first bracket has to multiply everything that is in the second bracket. That's why here we are having a multiplying everything that is in the second bracket plus I bar multiplying everything that is in the second bracket. But as we are doing this, as we are opening the brackets, we should not forget the identity that says that I squared is -1. So here, when we are open, we shall have ax plus a times iy, that is a iy, plus ib times x, that's I bar x, plus I bar times iy, this is going to be I squared by, and this will give us ax. This is having an I, this also having I, so we shall pull out the I and we have it as ay plus bx I plus, then this identity comes that whenever we have I squared, it becomes -1 times by. This will give us, we have here two terms that are not having I, that's ax, and the last one, only that the last one now is negative, and now also these two that we have put together that are having I, and this gives us ax minus by plus I ay plus bx. Now this shows that whenever you multiply two complex numbers, this becomes the real part, the whole of this bracket here, because it's not having the imaginary I, and the other one becomes the imaginary part. Say we take an example. If we are given z1, which is 3 plus 2i, and z2, which is 5 minus I, then multiplying z1 times z2, this becomes 3 plus 2i times 5 minus I. And as we said, this is opening brackets. Every element in the first bracket multiplies every other element in the second bracket, and this will give us 3 into 5 minus I plus 2i into 5 minus I. And as we open, we shall have 3 times 5, I think this is 15, 3 times -I, which is -3i, plus 2i times 5, we multiply the real ones, or we multiply the numbers, then the I comes next, so we shall have 2 times 5, which is 10, but it has an I, and then lastly we shall have minus 2i times I, that is 2i squared, and this becomes 15 minus, here we have minus 3i plus 10i. We first simplify this, that is this part here, you first simplify it if you have real values. So we have -3i plus 10i, this gives us plus 7i, then this I squared produces a -1, so we have it as -2, then I squared is -1, and we have this as 15 plus 7i, this negative and this will give us plus 2. So this element, or this term here and this term, they both don't have any I, so we bring them together, they have 15 plus 2 plus 7i, and 15 plus 2 becomes 17 plus 7i. after multiplication, let's look at the last operation. The last operation is division. And with division, what is more important is, friends, to recall the complex conjugate as we looked at it in the first lessons that we had in the first videos. We said that if you have a complex number a plus plus ib, then its conjugate, you change the sign. This is what is more important if it comes to division. So if we are given z1, which is a plus ib, and z2 x plus iy, and we are asked to divide, then whenever you're dividing, look at which complex number is in the denominator. Then after realizing it's x plus iy, we have to get its complex conjugate of the denominator. Now here we have x plus iy. We say that the complex conjugate of this complex number here is the number where we are changing the sign in the middle, which is x minus iy. So after getting that, we shall rationalize the denominator, just like the way you used to have it in the sides of O level. So here we shall multiply the complex conjugate up and down. And when we do that, we go back to the operation, which is the multiplication of two complex numbers. And here we shall have the upper part, we shall have a into x minus iy plus ib into x minus iy. Everything over. When we take the product of these two numbers that are in the denominator, this is a difference of two squares. It means that whenever you have the same numbers and the signs are different and you're multiplying, it's a difference of 2 squared, and this gives us x squared minus iy by the whole of it squared. And furthermore, up in the numerator we shall have a times x, which is ax. A times negative iy is going to be minus iay, then plus ib times x, that is I bar x, then ib times negative iy, this is going to be negative I squared by over. Now in the denominator we have x squared minus, this is going to be I squared, of which I squared is going to give us negative 1 times y squared, and this becomes, we collect those that are having I and those that are not having, shall have ax. This is having I, this is having I will start with the positive one, plus bx minus ay, then everything is having I, then this one is negative, but I squared, because we said it's a property, whenever you have I squared, it's negative 1, we shall have it as minus negative 1 dy, everything over x squared, this negative and this adds, plus y squared, and this gives us ax. This is not having any I, so I will combine it together with this, and I have it as plus by, because of this negative and that, plus bx minus ay, everything over x squared plus y squared. Now if it comes to separating the real and the imaginary parts of this, I will have the real part is these two terms that are not having I will have ax plus by over the denominator, which is x squared plus y squared, plus bx minus ay I over x squared plus y squared. That's how we that's how we divide, and we are also going to look at an example. So, looking at an example of how we can divide, say if you are given z1 and z2 of this form, then dividing, just bring the same complex number the way they are given, but what's important is to look at what's down and look for its complex conjugate. Here we have 1 plus I, so its conjugate, we change the sign. That is 1 minus I. After getting that, multiply it up and down, and you do the operation of multiplication. Opening the brackets up, this 3 multiplies everything. That's here. And then the 2I also multiplies the second bracket. And the downer part, I told you this is always a difference of 2 squared. But you get the first term squared minus the second term squared. That's 1 squared minus I squared. Then from the above, we shall have 3 times 1, which is 3. Then 3 times negative I, that's negative 3I. 2I times 1, that's 2I. And then 2I times negative I, that's negative 2I. But the I is here squared to give I squared. So we shall have 3. This one is having I, and this also has I. Meaning we shall have negative 3I plus 2I, which is negative I. And then also the last part here, we have I squared. And whenever we have I squared, it gives negative 1. So this gives positive 2, because we have 2 times negative 1, that's negative 2, but there is a negative in front to make it positive 2. So we shall have 3 plus, because this becomes plus 2 minus this I. And then the downer part, because we had 1 squared, which is 1, minus I squared also produced a negative 1, which cancelled with this negative to give a positive. So we have 1 plus 1, which is 2. And here, this part here is the real part. We have 3 plus 2 giving 5 minus I over 2. So from here we can separate, meaning we split the numerator with each one of them with its own denominator, having 5 over the denominator minus I over the denominator. All this can just be written as 5 over 2 minus a half I. Thank you very much.